This is question 2 in exercise 15.14 in Project Maths 2. The graph shows the length of the spring compared to the mass attached to it. So if we look at our graph just before we go into our questions, we've got our y-axis, which is labeled length of spring in centimeters, and we've got our x-axis labeled weight in kilos. Alright, so if we look for our first question, we've got how long is the spring when there's nothing attached to it? When there's nothing attached to the spring, then the weight would be 0 kilos. And at 0 kilos, if we go up to the red line, we see that the length of the spring is going to be 1 centimeter. So for part 1, our answer is just 1 centimeter. Alright, part 2, we're asked how would the graph be used to calculate the mass of an object? Well, what you would do is you would measure the length of the spring when a given mass is attached to it. Then you would go to that length that you've measured on the left, so for example say 15 centimeters, and you would work your way from there across to the red line just here. Then you work from that going directly down from that to the weight that's directly beneath it. And the weight directly beneath the red line when y is 15 is 8. So for a 15 centimeter spring, that represents an 8 kilo weight attached to it. And you just got to put that in your own words if you're asked a question like that. For part 3, we've got to find the slope of the line. The slope of the line can be found two ways. You can either pick 2 points and use your formula, which is y2 minus y1 over x2 minus x1, or you can use the rise over run method, which might be a little bit easier when you're reading it off a graph. So you pick a point where the line definitely intersects with two whole numbers on the a whole number on the x and a whole number on the y. So for example, the point 15,8 works, or 8,15 works just fine. And then what you do is we draw a triangle across from that. We form a little triangle with it. So we go across like that to there. And what we've got is we have our rise on this side of it and our run down the bottom. Our rise in this case goes from 1 up to 15, so that's going to be 14. And our run in this case goes from 0 over to 8. So we've got our m is equal to rise over run, which is going to be 14 over 8, which is 7/4, like that. So that is part 3, that's the slope of the line, just there. For part 4, we're asked how much longer is the spring each time an extra kilo is attached. Well, that information that's asked right after the slope question because they're trying to lead you into the answer. The spring is going to be 7 over 4 centimeters longer every time a new weight is attached. That's what our slope is saying. Our slope is saying every time the line goes across 1 on the x-axis, the difference on the y is going to be 7 over 4. So our answer for this one is going to be 7 over 4 centimeters or 1.75 centimeters, if you prefer it in decimal. For part 5, from the graph, we're asked to estimate the length of the spring using a 5 kilo mass. So what you would do for this is you would go over to your 5 kilos on your x-axis and work your way up to the line. And then from there, you've got to work your way across to the y-axis to find the corresponding length of spring. It's going to match up with that. Now that right there looks like it's about 9.7 or 9.8. And either answer would most likely suffice if you were asked this in an exam, because you're being asked to estimate rather than to calculate it directly. For part 6 of this, we've got to find the equation of the line. Now, the easiest way to do this would be to use the y equals mx plus c. The reason for that is that we know our slope m is 7/4, and we know c because c is where on the y-axis the line crosses, and it's 1. So in this case it's going to be y equals 7/4 x plus 1. Now if you want to make that a little bit neater, you can multiply across by 4 to get rid of the fraction. So 4y is equal to 7x plus 4, if you prefer. For question 7, we've got to use the equation to find the exact length of the spring when 5 kilos is attached. So we're trying to find the y value when x is equal to 5. So if we do that out, this is part 7. We're going to say x equals 5. So we're going to go y is equal to 7/4 times 5 plus 1. So y is equal to 35/4 plus 1, which is equal to 39/4. And if you tidy that up, that's going to be equal to 9.75 centimeters. So that's how we work out our y value when x is equal to 5 from this. Or in other words, we find the length of spring when the weight of 5 kilos is attached. For part 8 of this, we are asked to use two suitable values and show that if the mass is doubled, then the length of the spring is not doubled. In other words, we've got to pick two x values, one that is twice the other, and show that even though the x value doubles, the y value does not double. Our easiest two values to choose are going to be x equals 1 and x equals 2. You could use 2 and 4, or 3 and 6, or 5 and 10, but they're much larger numbers, less convenient. So if we take x equals 1 and we substitute into our equation, we get y equals 7/4 times 1 plus 1, which means y is equal to 7/4 plus 4/4. So y is equal to 11/4. Or if you simplify that, that's y is equal to 2.75. And if we do x equals 2, we're going to have y is equal to 7/4 times 2 plus 1, which means y is equal to 14/4 plus 1. So y is equal to 18/4. So y is equal to 4.5. And you can see that 4.5 is not double 2.75. So you have sufficiently shown what you're asked to show. And for the last part, part 9, you're asked why would this type of device be limited to a certain range of masses? The limitation on this type of device is down to the length of the spring and how far it can be extended. If the full length of the spring extended out is 15 centimeters, then you cannot weigh anything larger than 8 kilos. All you'll be able to say for certain is it's larger than 8 kilos. So you just got to put something like that in your own words down if you're asked a question on this in an exam. And that is that.